Hello everyone, my name is Sudhanshu Kumar. I am working as a data scientist in a product-based company. In today's session, we are going to talk about a Spark interview question, which is one of the important interview part for any big data developer or a data scientist. Spark is a in-memory processing framework. It's an in-memory processing engine. So we'll try to understand that in which area we should use Spark, in which area we should not use Spark. We'll try to get into a Spark architecture as well, and we'll try to discuss our internal components of a Spark through our interview questions. So the basic focus of this session will be on interview questions and what in all questions has been asked or it could be asked in an interview and how you should answer all of these questions. So now let's start with this session. Now let's try to understand that why we are going to choose Spark, why nowadays everyone preferring to go with a Spark. Before Spark, we have been using a different data processing engine. So one of the famous data processing engine I would say is a MapReduce. Still in some of the cases MapReduce is relevant, but let's try to understand that why Spark performs much better than a MapReduce. What is the difference between MapReduce and a Spark? So here let's try to understand these things through diagram. So as you can see in this diagram, so we are just trying to show that there is a Hadoop framework which is a MapReduce and a Spark framework. So Hadoop is our distributed system, it's a file system. So basically it will not process your data, it just try to store your data. The processing has been done by your MapReduce, but the problem with MapReduce is, so whenever you try to launch a iterative job, a iterative processing, so in this case, it will try to read a data for each and every iterative job from a hard disk, and then after each and every step, it will try to write back your data into a hard disk. Basically, it will be a HDFS file system. So every step, it is trying to read a data and write a data, and in between it consumes a network input output and it will perform a serialization and a deserialization operation to convert a data, and in this way it is going to utilize a lots and lots of IO bandwidth and it is going to consume your CPU while doing a serialization and deserialization operation. So suppose we have launched n number of a iterative job. So for this again and again it will read and write a data n number of times for each and every jobs, because MapReduce is a disk based computation engine. So every time it reads a data and writes back a data into and from the disk. Now let's try to focus over here. So Spark, whereas a in-memory computation framework. So while you are processing a data into a Spark, so it will try to keep your data, the intermediate data which it is supposed to provide to a next job, into a memory instead of keeping this data into a hard disk. So as you can see in this diagram, so it is reading a data from a hard disk, it is performing some operation in this step, and then it is writing your data into a memory. It is not writing back your data into a hard disk unlike this MapReduce. And again for the next step it is providing a data from a memory itself. Now again for the next step going forward it will provide a data from a memory itself. So as I said, Spark is a in-memory computation framework, whereas MapReduce is a disk based computation framework, and that's the first difference between MapReduce and Spark. Another difference between MapReduce and Spark is, so to process any SQL data, to implement any machine learning libraries, to implement or to do any streaming process, you can't utilize MapReduce directly. So to perform a SQL kind of operation, you are supposed to utilize a Hive framework on top of a MapReduce. To perform a machine learning operation, you are supposed to use a Mahout framework on top of a MapReduce. To perform a streaming job in a MapReduce, you are supposed to apply or use a Strom framework, And again, it's a burden on MapReduce, because again and again for each and every processing we are using some other framework on top of a MapReduce. So let's try to discuss about Spark in the same context. So Spark is having a Spark SQL libraries inbuilt inside it. Spark is having a machine learning libraries, MLlib. Spark is having a streaming APIs. Spark is having graphics. So Spark is a preferred choice than a MapReduce, I would say, because if you are using Spark, you are not supposed to look out for any other framework. Spark itself can handle so much of things than MapReduce. MapReduce process a data into a batch mode, whereas Spark process a data into batch mode or a streaming or a real-time streaming mode. And that's an advantage of using Spark on top of a MapReduce. So as we have discussed, MapReduce is a batch processing framework and Spark is a real-time or a near real-time processing framework. Spark provides integration with almost all the NoSQL database like Mongo, Cassandra, InfluxDB, Elasticsearch, Neo4j, HBase, and all sort of a database, relational databases like a SQL, MS SQL, Oracle, DB2, etc. Now let's try to understand that what is Spark. Why we used to say that Spark is 100 times faster than a MapReduce execution framework. So now, as you can see in this diagram, so Spark supports a batch mode processing of our data, as well as Spark supports a streaming of our data. Now, whenever you try to submit a job into a Spark, so the first point of contact for any program which has been launched from your client system will be a driver program. And inside a driver program, there will be a SparkContext, which is a first point of execution of any program. Now, this SparkContext will try to interact with your cluster manager. And as a cluster manager, you could use Mesos, you could use Yarn, or you could use Spark standalone cluster manager. So Spark provides basically a three kind of cluster manager: standalone, Mesos, and a Yarn. Now, SparkContext will try to get our resources from a cluster manager, and then after getting a resources, after getting a confirmation from the cluster manager that I have enough amount of resources to execute this particular job, it will try to launch an executor inside a worker node. An executor is nothing but we are talking about a CPU and we are talking about a memory, a RAM we are talking about basically. And as we know, Spark performs all the operation into a memory. So Spark is a in-memory data processing framework. So inside the executor, it will keep on executing a task in a distributed mode. If you are using a Hadoop cluster, if you are trying to execute your job into a standalone, again it will try to perform a same kind of operation. It will try to create a same kind of executor, but not in a distributed mode. And this is a basic diagram or the architecture you could assume for the Spark. We discussed about fundamentals of a Spark and what is Spark basically and why Spark. So we have discussed that Spark is an in-memory computation system. But whenever we are saying that Spark is an in-memory computation system, then we need to understand and we should know that what and all components are inside a Spark which supports a Spark or which provides a Spark a capability to process a data into a memory. So the first component I would like to discuss over here is RDD. So now let's try to understand that what is RDD. So RDD is nothing but a resilient distributed data set. Now let's try to understand that what is resilient, what is distributed, and what is data set. So resilient means it's a property of a Spark to achieve a fault tolerance in case of any job failure. So to achieve this fault tolerance, Spark always try to create a lineage graph. So it is nothing but a meta information about a processes that Spark is going to execute inside its executor. So it's basically a meta information. It's not about a data. So suppose if we are trying to process some of the job, and in that job we are trying to read a data from some file, from some hard disk, from some source system, and then we are trying to perform some of the operation like a MapReduce or a write operation. So for all of this sequential operation, internally it is going to create a graph, and that is called as a lineage graph. In that lineage graph, it will be having an information about a processes. So suppose if we are trying to do a read, map, reduce and write operation, so it will be having idea about all of this operation, not about a data. So whenever there will be a job failure, so it will try to re-execute a complete process from the very beginning till last, and this is how it achieves a fault tolerance with the help of a lineage graph, and which satisfies resiliency properties, and this is what a resilient means. Now let's try to understand a second keyword, distributed. So Spark can execute your data, Spark can process your data into a distributed system as well as into a non-distributed system. So basically it provides you a capability to execute a data with a bigger file into a Hadoop system, a HDFS system, and this is what is called as a distributed. Now let's try to focus on a third property, a data set. So you can execute or process any kind of a data set into a Spark. It could be unstructured, structured or a semi-structured data. There is no restriction with a kind of a data and a variety of a data. You could process any kind of a data, and this is what RDD means. So basically RDD is a primary data structure of a Spark. Now let's try to understand that what is SparkContext. So in our previous section we have discussed a Spark architecture, a very high level overview. In that session, so we had discussed that how Spark processes a job. So at that point of time we had discussed that SparkContext is a first point of contact for any Spark job. Now let's try to explore the SparkContext in a detailed way. So whenever your programmer is going to create a RDD, so a SparkContext will be a first point of contact to a Spark cluster by creating each and every time a new SparkContext. So each and every time it is going to create a new SparkContext whenever you will try to submit a job, and a SparkContext is an entity which is going to tell Spark that how to access a cluster. And in a previous section we have seen that a SparkContext was communicating with our cluster manager. It could be Yarn Mesos or a standalone. So a SparkContext always try to communicate with your cluster manager. It try to get your resources, it tries to submit your job, and then it will try to execute your job inside a executor by getting a resources from a cluster manager. And inside this SparkContext you can configure your Spark properties with the help of Spark configuration. So Spark configuration is a key factor to create a programmer application. So whenever you are trying to create some application, so always we used to set different properties like a local or a masters or a application's name. So all sort of things is been configured inside a Spark configuration. Now let's try to talk about partitions. So basically we had discussed about the RDD. So whenever you try to create or whenever you try to execute a job, so Spark will try to create a RDD for each and every bit of your data. But inside the RDD data will be available in bits and pieces. Those bits and pieces is been called as a partitions. So basically, partition is a logical division of a data, whereas RDD is a physical division of a data. So this idea basically is been derived from a MapReduce. So inside a MapReduce, there is a concept called input split, which tries to create a logical division of your data from a blocks. So in the same way, inside a Spark, you can create your logical division of your data with the help of partition, and RDD is a wrapping on top of your partition. So basically, RDD is a collection of a partition. Small chunks of data can be supported by a partition. So it's not like it should be having a one block of a data or 128 MB or 64 MB of a data. It can create a partition, and on top of that RDD even with a 1 KB of a data, and which supports a scalability, and it speeds up the processes with the help of in-memory computation. So input data, intermediate data and output data, whatever you process inside a Spark is basically a partitioned RDD. It's making very clear to everyone that what is partition and what is RDD. Now let's try to understand that how Spark partitions a data. So Spark uses a MapReduce API to do the partition of a data. Like a MapReduce, it was trying to do a input split, basically a logical division of a data out of your blocks. So same as in a Spark, in input format we can create any number of a partition, like we were creating n number of input split in case of a MapReduce. By default, HDFS block size is a partition size like a MapReduce. So by default 128 MB of data is equal to one partition, is equal to one logical division, I would say. But it's possible to change a partition size like a split, like an input split that we have been using inside a MapReduce. So let's try to understand that how Spark stores a data. So Spark is a processing engine, and as it is a processing engine, it is having no storage, but it's just having a computation power and in memory, basically a RAM, a primary memory. So it can retrieve a data from HDFS, from S3 or from a blob in case of Azure, and from any other data sources. Now let's try to understand that is it mandatory to configure your Spark on top of your HDFS? So the answer will be no. Spark supports a standalone mode as well as a cluster mode. So you can configure and you can execute your Spark program into your Windows machine as well as in a Linux machine, a individual Linux machine or a Mac machine, or on top of a cluster where you will be using a bunch of the machine, a bunch of the setup. But in terms of a storage, again whatever machine you are going to use, there is no separate storage in a Spark. So if you are using a standalone machine, so it uses a local file system to store our data. You can load our data from a local system and process it, or you can process our data from HDFS. But Hadoop or HDFS is not mandatory to run a Spark application. Let's try to understand that what are the basic components of a Spark ecosystem. So basically a Spark is having a Spark core in which you can process your data in a batch mode, and apart from that Spark supports SQL, Spark supports streaming, Spark supports machine learning libraries, and Spark supports graphics. So if you wanted to process a data like a Hive, which we were doing in case of a MapReduce, so you can process the same kind of data with a much more faster speed and less disk consumption into a Spark SQL. And a Spark SQL supports interaction with a Hive directly. The second component is a Spark streaming. So whenever you are trying to process a data into a real time or into a near real time, suppose if you are getting a data from a sensor or from satellite or from some BibLogs or some clickstream data, so in that case basically you would go with the Spark streaming APIs, and Spark can process your data into a real time with the help of discretized stream. Now suppose if you are trying to implement some of the machine learning modules, suppose if you are trying to build some models in a Spark. So Spark is having APIs for that as well. Spark supports almost all the advanced machine learning algorithm inside it. So like a clustering, classification or a regression. So all sort of operation you can perform inside a Spark machine learning libraries. Now the fourth thing is a graphics. So suppose if you are trying to develop a system in which you have to build or you have to work around with a network like LinkedIn or Facebook does, where LinkedIn and Facebook try to make a connectivity between one person to another person by storing some information into a nodes and then mapping a distance between two persons. So if you are trying to achieve a same kind of operation, you can do that with the help of Spark graphics libraries. Now let's try to understand that what is a Spark core functionality. So Spark core is a base engine for Apache Spark framework. So basically it does a memory management, it achieves a fault tolerance, it does a scheduling and a monitoring of your job, and it interacts with a storage system, which is a primary functionality of a Spark. So in terms of memory management, Spark tries to distribute your memory to a processes which you are trying to execute inside a Spark, and it will try to reserve some of the memory for cache memory. It will try to store or preserve some memory for some other processes as well. And fault tolerance it achieves with the help of a resiliency concept, which is nothing but it achieves with the help of lineage graph that we have discussed in our previous section. Scheduling means it will try to create a direct acyclic graph for each and every jobs, and then it will try to get a resources from a cluster manager, and then it will try to submit your job into an executor. That is called as a scheduling. And after submission of the job, it always tries to monitor your job, so whether your job is passed or a failed, and it will always try to make a communication with your storage system for reading and writing a data into a memory and from the memory. So this is a core Spark functionality. Let's try to understand that how Spark SQL is different from HQL, Hive query language, or SQL, structured query language. So Spark SQL is a special component of a Spark core engine that supports SQL and Hive query language without changing any syntax. And it is possible to perform all those operations that you perform inside a Hive or inside a SQL through Spark SQL. And it is possible to join even a SQL table and a HQL table inside a Spark. And internally, it optimizes your query with the help of a query optimizer, and it will try to optimize your data size as well if you are using a Spark query processor, Spark SQL, and that's an advantage of using a Spark SQL on top of HQL. So now let's try to understand that when do we use a Spark streaming. So Spark streaming is a real-time processing of a streaming API. Spark streaming gathers a data from different resources like a web server, log file, a social media data, stock market data, or a Hadoop ecosystem like a Flume, Kafka. So whenever you are getting a data in a fraction of a second, whenever there is a system which is generating a data so frequently that you are supposed to process within a second, then you should go with the Spark streaming. So whenever you are getting a data from a sensor or a satellite or a web server log, so Spark streaming is a better choice than any other processing framework in a real time. Now let's try to understand that how Spark streaming APIs works. So programmer always try to set a time inside a Spark configuration. So that time is nothing but you are setting a time for a particular stream. Suppose if I am setting a time of 15 second or 10 second for a particular stream, so Spark in a single process, in a single iteration, try to get a data for that many seconds. Now within this time, how much data it is getting into a Spark, that data has been separated into a batches, a small batches. Now the input stream, the data that you have inserted, is called as a D stream, discretized stream. Now it goes into a Spark streaming framework, and now a framework breaks up your data into bits and pieces, into a small chunks, and now it will try to form a small batches. So streaming is nothing but it's a collection of a small chunks of a batches of a data inside a Spark streaming framework. So basically whenever you are talking about a streaming, so in a background, so it is trying to treat your data in a batch mode. Now Spark streaming APIs passes a batches of a data to a core engine which will process your data, which will process your business use cases, and the core engine can generate the final result in a form of streaming batches again. So it has ingested a data in a form of batch and it is giving you a data in form of a batch, but again the ingested data was a batch of a streaming. Again the data that it is giving you as an output is a batch of a streaming data. The output is also in a form of a batches as we have discussed, and it can allow streaming data and batch data for processing. As we have discussed, Spark allows to process a data into a batch mode as well as into a streaming mode. Let's try to understand that what is Spark machine learning libraries. So like in case of a MapReduce, we have been using a Mahout as a machine learning library, but Mahout was not a part of a Hadoop ecosystem. It was an external framework that we have configured on top of a MapReduce, so that by the help of MapReduce execution engine we can process our data. But Spark itself provides a very rich machine learning libraries, same as Mahout. So inside a Spark, you are not supposed to configure some external framework. You can directly execute your machine learning models into a Spark. So it provides almost all sort of machine learning algorithm for a classification, clustering, and a regression problem, like a linear regression libraries, multilinear regression libraries, a polynomial regression libraries, support vector machine or a support vector regression, naive Bayes, k-means, knn. So it is having almost all sort of a very rich library. So you are not supposed to look out for any other external libraries. You can process all of your machine learning jobs into a Spark itself, and that is the reason most of the data scientists are using ML libraries from Spark. Now let's try to understand that what is a graphics module inside a Spark. So graphics is one of the advanced module, I would say, inside a Spark, which provides you a lots and lots of features and a flexibility. So graphics is a Spark API for manipulating a graph and a collections. It unifies extract, transform, load, and other analysis, and it provides a iterative graph computation. It is one of the fastest graph system which provides a fault tolerance and ease of use without having any special skills. So suppose if you are trying to solve a networking problem or a routing problem, so graphics will be having very rich features which could solve your routing or a networking problem. Nowadays we all are using social media, and in our social media, to route any people from any people, everyone uses a graph algorithm to build features. People use a graph algorithm and to combine features like a Facebook, a LinkedIn and a Twitter. So to make a relationship between one connection to another connection and to store a data, people are using graphics. If we are talking about any movie website like a Netflix or a Amazon Prime, they are using extensively this graphics algorithm in their backend. So there is extensive use cases of graphics, and you can achieve all of this operation in a easy step if you are trying to explore a Spark graphics algorithms. Now let's try to understand that what is a Spark file system APIs. So file system APIs can be used to read a data from a different storage devices like HDFS, simple storage services S3, or a local file system, or from any other storage system. Spark uses file system API to read a data from a different storage engines as well. You can read a data from any NoSQL databases or from a SQL databases as well. You can read a data from a sensors or a satellite or from any other devices as well inside a Spark. Let's try to understand that why partitions are immutable. It is one of the most important questions which has been asked in an interview. So every transformation, so whenever you try to perform any transformation operation like a map or a filter operation or a read operation, so it generates a new partition, because basically it generates a new RDD, and RDD is nothing but it's a bunch of partitions. It's a collection of a partition. So it will generate a new partitions for you, and partitions uses HDFS APIs like a input split, so that partition are immutable. You can't change the partition, but you can generate a new partition out of the previous one, and same happens with the RDD. RDDs are immutable. You can't manipulate a RDD, but you can generate a new RDD out of the previous RDD. These partitions are distributed and a fault tolerance. So it achieves a fault tolerance concept with the help of a lineage graph, and partition also aware of the data locality. So it will always try to create a partition in the system where the data is available at that point of time. It will not try to create a partition in some other system in which it will have to transfer or shuffle our data. This is how the partitions are immutable. Let's try to understand that what are the transformation functions which is available inside a Spark, or what is a transformation inside a Spark. And most of the time people ask lots and lots of questions on transformation. So Spark provides basically two kind of a special operation on RDD. So the first operation is a transformation, second option is a action. So transformation follows a lazy operation and temporarily holds a data until and unless a action has been called. So basically whenever you try to perform some operation, some transformation operation, so it will not try to load a data, or it will not try to read a data. It will just check your code syntactically whether it's correct or not, and it will not even execute your code by that time unless and until you are not calling some action on top of that. So basically transformation happens on top of a RDDs, and the output of the transformation is always a RDDs operation. Now as it's been mentioned over here, so each transformation generates or returns a new RDD, because RDD again it's an immutable concept. Now the examples of the transformations are a map, flat map, group by key, a reduce by key, filter, co-group, a join, sort by key, union, distinct. Samples are the common Spark transformation. So in all of this step, in all of this method, it is not going to execute your code unless and until you are not calling some action on top of your Spark operation, because transformation is a lazy evaluation inside a Spark engine. let's try to understand that what is an action operation in Spark. Like we have discussed in a previous section that what is a transformation, and we have discussed that transformation is a lazy evaluation. So unless and until you are not calling an action operation, it is not going to perform your transformation operation. So action is basically a RDD's operation that returns back a values to the Spark driver program, which kicks off a job to execute on a cluster. So when you call an action operation, so at that point of time, it is going to call your consecutive transformation operation, which will try to take an input from a transformation operation. So basically, transformation's output is an input to a action operation, and then it will try to give you a value as an output. So the output of any action operation is not a RDDs. Output of any action operation is a flat file or any other sequential file or any other file format, but input of any action will be RDDs. Now let's try to understand simple action operation. So the different action operation which is available inside a Sparks are reduce, collect, take sample, take, first, save as file, save as sequence file, count by value, for each. So these are the common action operation which we are using on a day-to-day basis. So this is all about action operation in Spark. What is RDD lineage? Let's try to understand that. So we have discussed that RDD is nothing but it's a resilience. Basically, it tries to apply a fault tolerance in a backend. But how it achieves a fault tolerance? And even at that point of time, we have discussed that it achieves a fault tolerance with the help of a lineage graph. So there, let's try to understand what is basically lineage is. So lineage is a RDD process to reconstruct a lost partitions. Spark do not replicate the data in memory because Spark always does a in-memory computation, and if Spark start doing this replication inside in-memory, then definitely you are going to need a huge bulk of in-memory, which is not physically possible. So if you are running a job and if your job is getting terminated and if you are losing your data, so RDD uses a lineage graph, which is nothing but a graph or a process overview or a meta information about each and every steps that you are going to process inside your job. So with the help of this RDD lineage, it will try to rebuild your lost data. So each RDD remembers that how it has been created or built from a previous or from any other data set, and by executing this again, you are going to build your lost data set again inside the system.
Acadgild. Average is dead.